For centuries, the gemstone world has been dominated by a handful of legendary names: diamonds, rubies, sapphires, emeralds. These gemstones became symbols of wealth, prestige, rarity, and power. They appeared in royal collections, museum displays, famous auctions, and luxury jewelry stores around the world. When people think about valuable gemstones, these are usually the first names that come to mind. But beneath the
Look at
surface of the
that.
gemstone industry, another story
Flawless
is
down to
unfolding.
bedrock.
A new generation of ultra-rare gems is quietly emerging. Most people have never heard their names. Many jewelers rarely encounter them, and even experienced collectors can spend years searching for a single fine specimen. Yet these gemstones possess something that could make them the collector legends of the future: extreme rarity, limited supply, unique geological histories, and growing attention from people searching for discoveries beyond the traditional gemstone market. History has shown that today's overlooked gemstone can become tomorrow's treasure. Many famous gemstones spent years hidden from mainstream attention before collectors recognized what made them special. The same process may already be happening again. And the first gemstone on this list entered history through one of the most unusual cases of mistaken identity the gemstone world has ever seen. Most gemstones are discovered in mines, mountain ranges, or river deposits. Taaffeite followed a completely different path. Its story remains one of the most fascinating in gemology. For years, specimens of Taaffeite were mistaken for spinel. Collectors owned them, dealers sold them, experts examined them. Yet almost nobody realized they were looking at an entirely different gemstone species. Everything changed when researchers noticed something unusual. The gemstone's optical properties did not perfectly match spinel. The data suggested that something else was happening. Further examination eventually revealed a surprising truth. The gemstone wasn't spinel at all. It was an entirely separate mineral species. Imagine discovering that one of the world's rarest gemstones had been sitting unnoticed in collections simply because everyone believed it was something else. That revelation immediately transformed Taaffeite into a gemstone of enormous interest. Its rarity had always existed. The supply had not changed. Only awareness changed, and that lesson appears repeatedly throughout gemstone history. Sometimes rarity exists long before people recognize it. Today, fine quality Taaffeite remains exceptionally scarce. Many collectors spend years hoping to encounter a significant specimen. Some never do. That scarcity continues to fuel fascination with the gemstone. But as remarkable as Taaffeite is, another gemstone became famous for an even more extraordinary reason. Its rarity became legendary. Few gemstones have developed a reputation quite like Painite. For years, Painite was considered one of the rarest minerals on Earth. Collectors discussed it constantly. Researchers searched for it. Mineralogists studied every known specimen. Yet very few people had ever seen one. Its scarcity became so extreme that the gemstone developed an almost mythical reputation. People weren't talking about Painite because it dominated jewelry stores. They were talking about it because it seemed almost impossible to find. That level of rarity captured imaginations around the world. How could nature create something so uncommon? How could a gemstone exist in such limited quantities? Those questions helped transform Painite into a legend. Additional discoveries eventually increased the number of known specimens. But something important happened. Its reputation never disappeared. Collectors continued to associate Painite with extraordinary scarcity. Even today, it remains one of the most recognizable names among ultra-rare gemstones. Painite demonstrates that rarity itself can become a gemstone's most powerful story. Its legend was built not on marketing, but on scarcity. And while Painite became famous because of rarity, the next gemstone attracted attention because people could hardly believe what they were seeing. Paraiba tourmaline, many assumed the color couldn't possibly be natural. Its electric blue-green glow appeared almost unreal. Photographs often failed to capture its intensity. Descriptions rarely did it justice. Many people needed to see the gemstone in person before they understood why it was so extraordinary. The finest specimens appear almost illuminated from within. Their vivid color immediately separates them from nearly every other gemstone in existence. Collectors quickly realized that nature had created something remarkable, and whenever nature produces something truly unique, attention follows. and many of the finest stones disappear into private collections where they may remain for decades. This combination of rarity and visual uniqueness has made Painite tourmaline one of the most fascinating gemstones of the modern era. Its story demonstrates how powerful a unique characteristic becomes when supply remains limited. But color is not the only path to rarity. Sometimes geography creates an entirely different form of scarcity. Most gemstones are found in multiple countries. New deposits can occasionally be discovered. Supply can expand. Markets can adapt. But some gemstones exist under very different circumstances. Tanzanite is one of the most famous examples. Its commercial production comes from a remarkably limited geographic area. That fact alone has fascinated collectors for decades. Every gemstone extracted from the ground reduces the remaining resource. Every year raises new questions about future availability. And every discussion about supply increases awareness of rarity. Collectors understand something important. A gemstone tied to one primary source carries a unique story. Its scarcity becomes easier to understand. Its future becomes easier to imagine, and its supply becomes easier to monitor. This geographic limitation has become a major part of Tanzanite's identity. Collectors
Of
are not only
Tanzanite
purchasing beauty,
because
they
they
are
can get
purchasing
it
a gemstone
same look
connected to a very
for a
specific
fraction.
geological circumstance.
And it's a
Because in the gemstone world, origin matters. Location becomes part of the rarity story, and stories often help define long-term collector interest. But even Tanzanite does not occupy the highest level of scarcity. Some gemstones are so rare that most collectors never encounter them at all. Among ultra-rare gemstones, muscovite occupies a special position. Many collectors know the name. Very few have seen a specimen. Even fewer own one. That level of rarity creates an extraordinary sense of mystery. Unlike mainstream gemstones, muscovite exists largely outside public awareness. It rarely appears in jewelry stores. It rarely enters everyday conversations, and it remains unknown to most people outside collector circles. Yet among serious enthusiasts, its reputation is enormous. Because rarity at this level is difficult to ignore. Collectors are naturally drawn toward challenges, and few challenges are greater than obtaining a gemstone that very few people have ever encountered. Muscovite represents scarcity in one of its purest forms. Its limited availability ensures that every significant specimen attracts attention. Sometimes the most fascinating gemstones are not the most famous. Sometimes they are the ones hidden beyond the spotlight. And when awareness eventually grows, interest often follows. But rarity alone is not always enough to create wonder. Sometimes a gemstone becomes unforgettable because it appears to do something impossible. Few gemstones inspire curiosity, quite like alexandrite. Its reputation is built upon one of nature's most remarkable optical effects. In daylight, it may appear green. Under warmer lighting conditions, it transforms into shades of red or purple. The change can be dramatic, and for many people it feels almost magical. Most gemstones remain visually consistent. Alexandrite does not. It changes, it surprises, it creates an experience. Collectors have been fascinated by this phenomenon for generations. Watching alexandrite shift color feels like observing two gemstones within a single crystal. That unusual characteristic gives alexandrite a unique position among rare gemstones. People do not simply admire it. They interact with it. They observe its transformation. They experience something unexpected. Exceptional, natural alexandrite remains difficult to find. Large stones displaying strong color changes are especially prized. And because nature rarely produces such remarkable optical effects, demand remains strong. Alexandrite proves that rarity is not always about scarcity alone. Sometimes it is about possessing a characteristic unlike anything else. And characteristics that cannot easily be replicated often become highly valued by collectors. What separates ultra-rare gemstones from many luxury products? The answer is simple. Nature controls the supply. New deposits cannot be created on demand. Geological history cannot be manufactured, and collectors cannot increase availability. The number of exceptional specimens remains fundamentally limited. This creates a powerful dynamic. Awareness can increase, demand can increase, interest can increase, but supply often changes very little. Throughout history, Some of the world's most desirable gemstones became valuable because people finally recognized rarity that had existed all along. The gemstone itself did not become rarer. Public understanding changed, and that change transformed everything. Listen closely. That sound? It's the sound of a fortune hitting the garbage. Every single day, in every city, on every construction site, the most valuable diamonds on Earth are being thrown away. Not because they aren't there, but because they are ugly. Today, we stop the waste. The rocks that look like trash, but hold the treasure. Rock number 1, kimberlite nodules. The dirty potato. Look at this. It's a rounded, lumpy stone. It's dull gray. It feels slightly soapy to the touch. To a construction worker, it's just more fill. To a geologist, this is a kimberlite nodule. Kimberlite is the primary source of diamonds. But here is the shocking part. When kimberlite reaches the surface, it rots. It turns into something called yellow ground. It looks like dried, cracked mud. It looks like something you would scrape off your boot. Most people see a yellow dirt clod and toss it. Inside that clod is the matrix. Diamonds don't just sit in the dirt, they are embedded in this ugly gray-yellow clay. Why is it thrown away? Because it's soft, it's messy, it's rotten. But the rot is the key. The minerals have oxidized, the iron has changed. But the diamond is chemically inert. It survives the rot. If you find a patch of yellow ground in a field of hard granite, you have found an elevator to the mantle. Don't throw the mud away, wash it. The trash is the treasure chest. The yellow ground mystery. Why is it yellow? Oxygen. The deep earth is an anoxic environment. No air. When the rock hits the atmosphere, it breathes. It turns from blue to yellow. It crumbles. This crumbling is a gift from the earth. It makes the extraction easy. In the 1800s, miners threw this yellow dirt aside. They wanted the blue ground. They thought the yellow stuff was dead. They threw away millions of carats for years until one rainstorm washed the dirt away and revealed the sparkle underneath. Are you making the same mistake? Are you ignoring the rot? Rock number 2, eclodite, the greasy slag. Next up, the green and red disaster. It looks like a piece of burnt pizza. Dull green spots, deep red spots, burnt black crust. Most people find this in a river and think, pollution. They think it's waste from a factory. This is eclogite. In the high-end diamond world, eclogite is legendary. It is the diamond-bearing rock of the deep crust. Those red spots, pyrope garnets, those green spots, amphicite. When these two meet under extreme pressure, they create the perfect nursery for type 2A diamonds, the purest diamonds in existence. But here's the catch. Eclogite is heavy. It is dense. It doesn't look like a gemstone. It looks like a heavy, ugly stone. Because it is so dense, it sinks to the bottom of rivers. It gets covered in algae. It looks like a slippery black rock. You kick it, you throw it. You just threw away a diamond host. Break it. Look for the octahedrons. Look for the triangles. Nature doesn't make triangles by accident. Diamonds do. The density trap. Why do we miss it? Gravity. Eclogite is 30% heavier than standard river rock. Pick it up. Does it feel wrong? Does it feel like it's made of lead? That density is the signature. The Earth compressed this rock 100 miles down. It packed the atoms so tight that it created the hardest substance known to man. If a rock punches above its weight, it's not trash, it's an asset. Rock number 3, peridotite, the scaly deceiver. Look at this one. It's olive green, but it's covered in a scaly black skin. It looks like a reptile turned to stone. Most people see old lava, they throw it back. This is peridotite, specifically lherzolite. This is the parent of the diamond. If you find this rock on the surface, something violent happened, a xenolith event. The magma moved so fast, it ripped a piece of the mantle out. It carried it to you. The scales are the burn marks of the journey. Inside those scales, the mantle's samples. This rock is 90% olivine. But that 10% is where the diamonds hide. They hide in the interstices, the tiny gaps between the green crystals. Most people see a grainy green rock. They call it sandstone. They are wrong. Sandstone is light, peridotite is heavy, sandstone is gritty, peridotite is crystalline. If you see a green rock with snake skin, you are at the door. Don't walk away. The snake skin code. Why is the skin black? It's called a chelophytic rim. It's a chemical reaction. The garnet inside the rock is trying to turn into graphite. It's a race against time. The black rim is the scar. If the rock stayed underground longer, the diamond would be gone. It would be pencil lead. But because it cooled fast, the diamond is trapped inside the snake skin, waiting for you to find it, waiting for you to realize. That ugly isn't a flaw. Ugly is a shield. Rock number 4, lamproite, the burnt brick. This one is a classic. It looks like a piece of an old fireplace or a crushed brick from a demolition site. It's reddish brown. It's full of vugs, holes. It looks like it was in a fire. In Australia, this burnt brick created the Argyle mine, the source of 90% of the world's pink diamonds, the most expensive gems on the planet. And for decades, farmers used this rock to build roads. They used it to fill holes. They threw it away as bush rock. Why? Because it's tough. Volcanic ash turned to stone. It's brittle. It's boring. But inside those burnt bricks, the pink fire. The Argyle mine is gone now. It's closed. But the lamproite belts are still out there. Across the US, across Africa, across the world. People are still building driveways with ugly brick lamproite. They are driving over pinks. They are driving over red diamonds because they don't know the porous rule. The porous rule. If a rock looks like a sponge, but it's made of stone, it's vesicular. It means gas was trapped in the magma. Gas means high pressure. High pressure means diamonds. Don't look for the shiny rock. Look for the sponge. Look for the rock that looks like it's been through a furnace. Because it has. And the furnace of the earth only makes one thing that survives. Carbon, crystallized, perfect. Rock number 5, alluvial diamond, the frosted glass. Finally for part 1, the industrial waste. You are in a creek. You see a piece of glass. It's rounded. It's dull. It looks like a piece of a broken beer bottle. That has been in the water for 20 years. It has a frosted look, like a window in winter. You pick it up. You think, pollution. You toss it back into the water. Stop. You just threw away an alluvial diamond. Raw diamonds are not clear. They are not sparkly. They have a skin. In the trade, we call it the gum-like luster. It looks like a piece of unchewed gum. It looks greasy. Water rolls off it. If you see a piece of frosted glass that won't get wet, you have found the king. Why is it thrown away? Because people expect a star. They get a pebble. They expect fire. They get fog. But the fog is only on the surface. Inside, a deflawless masterpiece. Wait for the pause. Wait for the shift, the cliffhanger. We have covered 5. The mud, the slag, the snake skin, the brick, the frosted glass. None of them look like wealth. All of them are being thrown away right now. But we have 5 more. And the next one? It's the most common rock in North America. And it's the #1 reason why people are accidental millionaires. It looks like a common black river stone, but it holds the carbonado, the black diamond from space. Are you ready to see the rest of the trash? Stay sharp, stay focused. The earth is hiding her fortune in plain sight. I am Pro Gems, and we are just getting started. Rock number 6, carbonado, the space trash. Look at this one. It's jet black. It's porous. It looks like a piece of charcoal from a barbecue or a chunk of asphalt from a pothole. Most people see industrial waste. They think pollution. They are wrong. This is carbonado, the black diamond. In the market, collectors pay thousands for raw specimens. In the lab, they are a mystery. Why? Because carbonados aren't found in kimberlite. They aren't from the mantle. They are found in alluvial deposits in Brazil and Africa. Their chemistry says they came from space, a supernova explosion billions of years ago, raining down on Earth as black, ugly chunks. Why are they thrown away? Because they don't look like gems. They don't have a single crystal face. They look like scoria or volcanic lava. But try to break it, you can't. Carbonado is a polycrystalline structure, thousands of tiny diamonds locked together in a black embrace. If you find a black rock that feels metallic but looks burnt, and your steel hammer won't leave a scratch, you aren't looking at a charcoal. You are looking at a star. The unbreakable test. How do you know? Use a hardness test. Most black rocks are basalt or hematite. They are soft. They will crumble under a heavy blow. Carbonado? It will laugh at your hammer. It will dent the steel. If the rock bites the metal, you just found a diamond from the heavens, thrown away as road tar for 100 years. Until now.